Hey everyone! Welcome back to Rust Tutorials, the go-to place for all things programming and software design. I'm Ida, and today we're delving into the fascinating world of design patterns, specifically the active object pattern in Rust. So, grab your coding hats, because we're about to explore how this pattern can make our systems more flexible and concurrent. Now, have you ever found it handy to separate things when a method is called from when it actually runs? It's precisely where the active object design pattern shines. It allows us to build more flexible and concurrent systems. What's the key feature, you ask? Well, every method call is wrapped up in an object and placed in a queue. This queue is then processed by the active object in a separate thread. Sounds intriguing, right? But let's not get lost in theory. We're going to simplify it with a practical example in Rust. So let's dive into the implementation details in Rust. We're going to create a basic logger because, let's face it, logging can get complex, especially when dealing with external databases or web services. In such cases, it's efficient to delegate the writing process to a separate thread. But before we get into the nitty-gritty, let's set up the basics. We'll use the different log levels represented by an enum, and we have a log message struct that holds the log level and the log message. And there we go. Now on to the heart of our pattern. We'll implement the queue message enum. This is where the power of Rust enums really shines. And with that, we create the active logger struct. This is where the magic happens. And there we go. I'll make this a little bigger so you can see the whole thing. A quick note here. The active logger has an MPSC sender to send messages to the logger. In the constructor, we spawn a thread to receive messages. The run method sends messages to the logger, including the processing function and the message. And when it's time to call it a day, the terminate method sends a termination message to stop the logger. Let's see if it works. Testing time. We'll replace the main method with this. And there you have it. Rust's fearless concurrency makes implementing the active object straightforward. This pattern proves useful in various scenarios, from message processing to printer spooling or even chat applications. It truly excels in situations where separating method execution, from invocation and handling tasks concurrently brings significant benefits. Well, that's a wrap for today's vlog. I hope you enjoyed our journey into Rust programming and the active object design pattern. Don't forget to hit that like button, subscribe for more content, and leave your thoughts in the comments below. But before we go, let's see if it works. Ah, yes, of course. I should have added the struct. I'm sorry. See, even I make mistakes. Now it should run. Yeah, it does. As you can see, it's terminating, and after that it prints hello world. That means it's multi-threaded. Okay, thank you for watching, and see you on the next one.